this work? How the spanning tree protocol is going to decide which port is going to block, which port is not going to block, which port is going to forward data, which port is not going to forward data. You know, how do you do that? I'm sorry? The first thing, let's look at, well, maybe I'll look at this. Let's see what topology I have in here. So I have something like this. So first of all, every switch has what we call this bridge ID or bridge priority. So this is the BID here, in this case. The bridge ID is 2 bytes. So it's 16 bits. So it can go anywhere from 0, the number. It can be from 0 all the way to 65, 535. And in this case, 65, 535 by default is set to 32, half of that, 32 to 768. So the BID, the bridge ID on all of these switches are all set to 32 768, and this one 32 768, and this one 32 768. So you can change that number, and you can make it anything from 0 all the way to 65 535. Okay, but by default, if you turn on any Cisco switch, it is by default set to 32 768. So all these 3 switches are set to the same bridge ID, which is 32 768. That's one of the tools will be used by the spanning tree protocol to choose which port finally it's going to block. Okay. The other thing that it goes into consideration is the path cost, which is the link in here. The path cost is basically the link So this is, I don't know, let's call this a switch A, switch B, and switch C. So let's say, for example, the path cost depends on the bandwidth, of the link.
I like that.
So whatever is this, 10 meg, what are we connected here? 100 megabits or 10 megabits? We're most likely not 10 megabits, correct, guys? the first the first one was really yeah, the new one. Let's look at the new one. The new one is based on 100 megabit. If it's 100 megabit link, then the cost is STP cost is 19. So that's for 100 megabit link. For 1 gigabit link is 4. And for 10 gigabit link is 1. So these are the numbers for the I'm sorry, 10 gigabit is 2. So it's 2, 4, or 19 for that. And they updated it again. It depends on really which one the switch you have, because there is new ones that can go to 10 terabits, which is 200 gigabits, 10 gigabits. So we'll stick to this one because most of the switches are either 100 meg or 1 gig. We don't have any 10 gigs. You know. So the cost, you will see these numbers, so you need to know what these numbers. So if these were all the switches we use, these are all what? 100 megabits per second, correct? 100 megabits per second, 100 megabits per second, 100 megabits per second, 100 megabits per second, and the same thing. So this cost is 19. The cost here is 19. The cost here is what? It's 19. So the path cost is the sum of all the costs to go from switch to switch, from one switch to the other switch. So, for example, for switch B to go to switch A, the cost is what? It's 19. For switch B to go to switch C, okay, it's 19 plus 19, 38 this way, or 19 this way, okay? For switch A to go to switch B, the cost is 19. Switch A to go to switch C, the cost is 19. Also, switch A can go to switch C this way with a cost of what? 38. Okay? So this is another tool that is going to be used by the spanning tree to figure out how to block the ports. Okay? So far we haven't got into the spanning tree. This is just some of the stuff will be used. So you need to know the path cost, you need to know the BID or the bridge ID for that. All right, so this STP step or the STP process in this case, I'm going to summarize it in 4 steps. The first one, determine the root switch. So one of the switches is going to be the root on the top level. Everything is underneath it. Okay? Who is going to be that root switch? Okay?
Core switch?
Any of them right now can be. Like in this topology here, any one of them can be, because so far all the numbers are equal. The path costs are the same, and the BIDs are all the same. Okay? So determine the root switch is basically who is the, in this case they call it the